Hi guys, so we're starting on 4.3 congruent triangles. Please make sure that you have a highlighter because we need to highlight. Please make sure you have a calculator. And then when you're doing your assignment, please make sure that you have a piece of scratch paper. That is going to be hugely important. I cannot stress the importance of taking good notes. The majority of you do. I'm going to be checking them to make sure you are staying on task, not to just be mean and grouchy. It is because I want you to be successful. This is a time for you guys to be independent. I get that. But you do need to know the proper way of learning, and taking notes is one of those things. It's one of those things that we do not just because we want you to have a copy of it. It is because the art of writing it out makes it stick in your brain. Okay, so let's get started. So congruent triangles, that means these are equal triangles. And we have a lot of different things to cover here. So, two polygons are congruent if and only if their corresponding parts are congruent. So they're corresponding, I don't know if I can get that in there, corresponding, squeeze it in, parts are congruent. Okay. So, and if you look here, you can match these up by their little tick marks. So you know that KH goes with AC. So that's line, we'll put KH. What goes with BC? That's got 2, that's KJ. AB has 1, so that's JH. And it doesn't matter which order you go. Angle A has 2 tick marks, so that goes with H. J has 1, so it goes with B. And C has 3, which would go with K. So matching, you're basically matching. Now this is an important concept, is to making that congruent statement. So I'm going to go along with this. So when you're looking at a congruent statement, I like to write it up and down. So what matches A? That was H. What matched B? That was J. What matched C? That was K. So this would be my congruent statement, and I cannot stress this enough, is to write it up and down so you can immediately see your matching angles and your matching sides. So AB goes with HJ, CA goes with KH. So you can really, it's just an amazing visual, and I think that's going to help you in geometry. Now, this is something that we also use quite often. It is the corresponding parts of congruent triangles are congruent. So that's what we're talking about. It's called your CPCTC. You love that? And you'll see that when we're doing proofs. All right, this next one. If 2 angles of one triangle are congruent to 2 angles of the second triangle, then the third angle of that triangle must be congruent. Okay. So A and L would be congruent. There you go. Some of these are just basic, but they're important. That's the third angle theorem, and you're going to use that. Third angle theorem. Next one, properties of congruence, and these words should be familiar with. Reflexive, so it's equal to each other. Symmetric, so it's written backwards. So this statement is backwards of that statement. Transitive, if this is this and this is this, that means these two go together. Okay, so transitive. Already know those. Down here is showing that they are congruent by identifying all their corresponding parts. So what would make it super easy for me, and basically I'm going to say, I'm going to start with EDC, BA will match QSP, TR. So now I've got this visual that these two are matching, and now I can say, okay, Angle E is congruent to angle Q. Angle D is congruent to angle S. Angle C is congruent to angle P. Angle B is congruent to angle T. Angle A is congruent to angle R. So those are by angles. Now the sides. ED is congruent to QS. DC is congruent to SP. CB is congruent to PT. BA is congruent to TR, and AE is congruent to RQ. And that's without even looking at it. So this statement, like I said, written up and down, you can do it this way or just lose your mind trying to read that. This is the way to go. Next. So what do we have from this? In this diagram, this triangle is congruent to that. So let's find the values of X and Y. So if we know, I'm going to rewrite this statement so it's up and down so I know what goes to what. Quickly. Okay, so if I'm looking at O, that's going to match P. How much is P? 40 degrees. So this is going to match that. And you could just mark it like that as well. But looking at the statement, you automatically know what matches. All right, so we know that 6y minus 14 is equal to 40. And let's solve that. Okay, so y equals 9. Let's see. And then we need to find NG. So NG's here, and that is IT. IT is 7.5. So x minus 2y is equal to 7.5. Y was how much? 9. I need to put that in here. So x minus 18 equals 7.5. Add 18. Oops, I don't know why I'm doing that. X is equal to 25.5. I'm getting ahead of myself. So here's your x, and there was your y. Again, all because we have this congruent statement. I just rewrote it up and down. I'm going to do the same thing here. FHJ goes with HFG. Okay, so something I do want to show you, anytime that you have this, this is considered a parallel line, okay, to this line. These are parallel. So that should let you know that these are interior angles and they are congruent because this is my transversal. So please keep that in mind. So F and H go together, but we kind of can see that anyway because of that transversal. So if we're finding X, we could say 6X plus 8 is equal to 35. So again, angle F goes with angle H. Minus 8, 6x is equal to, what is that? 30, this is the one I always forget. 8, 3 minus, 27? Did I do that wrong? Get my calculator out. No, I didn't. So you can leave it like this or change it to a mixed number. Don't care. I like to leave stuff as improper as long as it's simplified. My next one would be, obviously, let's see, FJ. So FJ, so that's GH. So these two are equal to each other. So 2y minus 3 is equal to 2.5. Add 3, 2y is equal to 5.5 divided by 2. So here is my y equals. And there you have it. Next, I know you guys are super excited, but you have proofs. Let's see what we already know. So if looking here, you should know that this angle and this angle are congruent because they're vertical. So I'm going to go ahead and mark them. You're going to do that so many times this year. Know that they are vertical. What else? I'm actually going to change the markings because this only has one, because these could be a different size, so I'm going to make them both 2. Okay? So given is all this stuff. Now we're saying that LNM is congruent. LNM is congruent to PNO. That angle. So angle LNM, so that's that angle here, and PNO. So again, this angle. They are congruent because of vertical angles. They are vertical angles. Next, third angle theorem. Therefore, angle M must be congruent to angle O, because if these two are congruent, that means these two are congruent. And then we are proven would, because of those congruent parts are congruent, that's the final. And you're going to use this one quite often as well. All right, let's try this one. So on this one, we have our given. NP is equal to NP, and you'll get this a lot. So this line is congruent to this line because it belongs to both. So that's reflexive. It's equal to itself, and it belongs to both triangles. You are going to use this one often. And then here's more information that's given. And then QNP, so QNP, that angle here, is congruent to ONP. So these two are congruent. Did it say they were congruent? Where does that say that? Well, I'm going to mark these. These two are congruent. So again, this is going to be that third angle theorem. Let's see here, because it says angle O and Q are congruent from our given, and it said angles, any other angles? So that's congruent. These two are congruent. I feel like I missed one. QN, those are congruent. These are our angles. These are, so N and P are the same. P and N. Oh, I see what it's saying. I missed this one. So this one goes with this one, and then I'm going to do 3 here. There we go. I should have read my proof a little bit better. And then they are congruent because the definition of congruent polygons. This one, angle theorem, trying to know the difference between this and that. So that'll be practiced. Okay. Is that it for this one? It is. All right, so if you want to take a break, you can and work on your assignment. Otherwise, I'm going to plug ahead. All right, this one. Side, 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 side angle, side. So that means looks a little different than I thought. If you could see this, if your sides, like this one is marked, this side goes with, that angle goes with this side. We've talked about that. And if these are different, that means these are going to be different. So I'm going to mark this with 3. I really want to mark this one with 3. That way you can see that. This one with 2, and then the opposite of this one will make 1. So it goes by opposite. This angle goes with this side. If this is a certain thing, it matches this. If this is the biggest angle, this is the biggest side. If this was the smallest angle, this would be the shortest side. And that is called side, side, side. So you've got all those sides that are congruent. Okay. Included angles. This is if included means it falls between two sides. So let's do this. Angle falls between two sides, given. Okay, so you have here, and then you have this marked and this marked. This is called an included angle. It's included, it's called side, angle, side. Side, angle, side. This one up above was called side, side, side. All right. And I talked about the sides opposite of. Okay. So this angle goes with that side. If 3 sides of one triangle are congruent with 3 sides of a second triangle, then the triangles are congruent. Side, side, side. Okay. Trying to see. Here's some other examples of that. So you can see this side and this side, you've got 2 triangles here, but since they share this, it's the third side. So this would be another visual of a side, side, side. And the same thing with this one. This one would be a shared side. I'm going to mark that like that. There you go. Okay. So you still have side, side, side. Looking for clues when you're doing your proofs. This next one is side, angle, side congruence. So if 2 sides and the included angle, remember that included angle, of one triangle are congruent to 2 sides and the included angle of the next one, then the triangles are congruent. So again, you can see this is called an included angle because it's in between these 2 sides. So that's a visual of that. Here you can see that again, these are vertical angles. So these would be the same, and this would be like an included angle. So this would be a definition of side, angle, side. So side, angle, side. It's included. Okay. Now we're going to determine if these are congruent. So I'm going to rewrite my congruent statement. So ABC goes with DEF. Okay, so let's plot these. -5, 5. I'll let you plot them and I'll be quiet. I'm going to use my straight edge, if I can find it. There he is. Again, we're going to find these diagonals by using the distance formula or the Pythagorean theorem, and I should have labeled these. So this one was A, this one was B, and this one was C. I'll do the next one. This one's going to take a little bit longer only because there's so many sides to check. So I'm going to check AB, does it go with DE? So I'm going to write that AB congruent to DE. Let's check it out. So A to B, we're going up 2 and then over. So AB is 2 squared plus, what did I just say, 5 squared? And that's going to equal the square root of something. Where's my calculator? Sure, what is that, 29? 2 squared plus 5 squared equals the square root of 29. And then D to E, so up 1, oops, D to E, so I'm going down 2 over 1, 2, 3, 4, 5. Well, that's the same thing. So, yeah, these two are congruent to each other. Those two are. That's so far so good. Let's check the next one. BC and EF. So B to C. So I'm going to go over 4, 2. 4 squared plus 2 squared. What is 16? Is that square root of 20? E to F. 1, 2. 1, 2, 3, 4. Same thing. So far, so good. Next one. What are we? CA. Is it congruent to FD? I kind of hope it is. So this one I'm going down 1 and over 1. So it's 1, 2, 3, 4 squared plus 1 squared equals, what is that, 16 plus 1, 17, square root of 17. And this one, F to D, so up 1, 2, 3, 4, 1. Yes. Look, it's actually congruent. So yes, they are congruent to each other. Yes, yes, and yes. That was kind of fun. All right, next, our favorite. This time I'll do a much better job than I did with the last one. The other one, I don't think I did. And by the way, looking at this, why did this work? Because all the sides were equal. Since the sides were equal, we would say side, side, side. Because that's what we were talking about. All right, so let's label these. I did not do that on the last one, and I apologize, but let's do it here. So they're giving us stuff, and I'm always the visual. So angle ABG. So where's that angle? ABG. Assuming this is A. Okay, so this is the angle, since B is in the middle, that angle, and G. So this is congruent to this, is what they're saying. And then side AB is congruent with CG, so we'll mark that. Okay, so I have a feeling since they share this side, we're going to say those two are congruent to each other. BG is, I can now already tell you right now, that's what it's going to be. So given, We just did that. And then we're going to say this is because of side angle side, because we have side angle side. This one was easy. So we're going to say BG. So segment BG is equal to segment BG. And that is reflexive. Don't you wish they were all this easy? All right, where else are we going? That is it. All right, happy assignment. If you have any questions, let me know.